Hello students. Here we'll discuss about Ngram language model. So before seeing what is meant by Ngram language model, let us try to understand what is meant by this language model. So language model in NLP, it is a probabilistic statistical model. So that mainly predicts or determines the probability of a given sequence of words occurring in a sentence based on the previous words. So we can say that it helps to predict which word is most likely to appear next in the sentence. So best example is our mobile phone keyboard, right? So see the first example. So when you start typing something, typing a message, then you can find out some words which are related to the sentence. So how you are getting those words? So that is because of language model, right? So if I type something like I had such a, then automatically the machine, it will, or the model, it will try to predict the next word. And it is giving you few suggestions like great, great time, lovely. So this is because of language model. And then you can even take one more example. See, when you start typing something or any text in Google search bar, there also you can see multiple suggestions, or it will try to fill the piece of word after the sentence. So first you will enter world, then you'll get various suggestions or words which are similar or which can fill the next part of the sentence. So that also happens because of the language model. So here language model, it runs in the background or back end. When it takes an input, it will suggest you these words. Now, so what can be different other examples of language model? So here we can say that this language model, it forms the backbone of our natural language processing. So they have various applications in various domains like it can be used in speech recognition, machine translation, spelling correction, etc. So the input to a language model is usually training set of example sentences. So we'll provide a training data which is having multiple examples or multiple sentences as input, and output will be the probability distribution over sequence of words. Now let us go into Ngram language modeling. So in fact we can say that this is the example of a statistical language model, the first type of language model, and second type is neural language model. So let us discuss about this Ngram language modeling. So we can define it as a contiguous sequence of n items from a given sample of text or speech. Say suppose if training data with multiple sentences, so that is nothing but a text, right? So if that text is given as input, then in that case this we can define or we can say that Ngram is a collection, contiguous sequence of n items from that text. And here, what are items? So I'm telling you that it is a contiguous sequence of n items. So what is meant by this item? So item is nothing but it can be either letter or it can be a word. So Ngram, it typically they are collected from a text or speech corpus. So then, so why we need this Ngram language model means? So if you take a best example, suppose if I give the system the sentence, thank you so much for your. So if that is a sentence and we want the system to predict what the next word will be. So here, as we are human beings, we can identify or we can predict the next word as help with a very high probability. Because when a person will thank any other person, so if they receive some kind of favor or help from them, right? So we can predict that the next word can be or it might be help. But how will the system know that? So, in order to predict such kind of things, we can use this engram language modeling. So, why is it that we need to learn engram and related probability? So, that's what we discussed right now, right? So, why we need to learn means, or in order to predict the next word in the given sentence. So, this is used in various applications like auto completion of sentences. So, just now we saw that example. So, when you type something, then the model it will try to complete the sentence by suggesting you words by predicting the next word in the given sentence. And auto spell checkers, so even it is used for shelling, it is used for checking the spelling mistakes also. If you by mistake if you type some wrong spelling, then also it will make the correction automatically. And also we can check for grammar in a given sentence also. So how are these engrams classified? So here engrams, they are mainly classified depending on the value that n takes. So the first one is, so here you can see different types of n-grams. First one is unigram, where n value is equal to 1. Second one is bigram, where n value is equal to 2. Third one is trigram, where n value is equal to 3. And last one is, so you can have any number of terms like this. And in like that, you can have till n-gram. So in this case, what is meant by unigram? So for defining this unigram, we don't need any history or we don't need any previous words in order to determine unigrams. Whereas bigram means we can predict the next word based on the previous word. So that is nothing but by. So if you want to predict, say suppose these are three words in a sentence, and I want to predict this third word. So I can predict this based on the previous word. So here I'll be using the history or data, one word history or one word data. So the word which is previous to the word which I'm going to predict. And trigram. So in this case, we'll take the history of previous two words. So I want to predict this word, fourth word. Then I'll take the help of previous two words for prediction, and so on. So we'll see more about this with examples. So when n is equal to 1, it is a unigram. When n equal to 2, it is a bigram, and so on. So let us take one example. Say suppose the given sentence is I reside in Delhi. How to represent this using different categories of n-grams. If it is a type of n-gram, so where n value is equal to 1. So in this case, n-grams generated are, see you can find only single word. Uni is nothing but single. So you can represent unigrams like this. Whereas bigram means you can find out sequence of two words. I reside in Delhi. Trigram, it's a sequence of three words, right? So then, coming to this Bayes rule, so we'll be using Bayes rule in this n-gram language modeling. So first, let us understand what is meant by this Bayes rule. So we are already familiar with Bayes theorem and Bayes rules. So you can represent Bayes rule by using this equation, right? P of, so probability of A given B, which is equal to probability of A and B occurring together given and it should be divided by probability of B. So it can even be written as, you can even write it as probability of A and B happening together is equal to probability of A given B into probability of B. So this, you can use this when two variables are given to you. What if the number of, if the variables are more than two? Say suppose if I have four variables, then I can write this equation as P of A, P of, or a probability of B given A, probability of C given AB, probability of D given ABC. So this equation, we can represent this equation using this chain rule. So this is a chain rule, right? So you can write the above equation as probability of x1, x2 and so on, xn. So you can have any number of words, and which can be written as probability of x1 into probability of x2 given x1, probability of x3 given x1, x2 and so on, probability of xn given x1, x2 and so on, xn minus 1. So this is used when we have more number of variables, say suppose n number of variables. So we can modify this formula to represent the probability of words in sentences. So you can use the same formula for finding the probability of words. So you can write this as probability of W1, W2 and so on, Wn. So instead of using this x1, x2, as we are finding probability of words, we can write it as W1, W2 and so on, Wn equal to pi I, and this is P of Wi given W1, W2, W3 and so on, Wi minus 1. So this I value, it will range from 1 to n. This I is equal to 1 for unigram and it is equal to 2 for bigram and so on, n. So then, what is this unigram probability? So you can define this unigram probability as count of W by N. So what is this count of W? So W can be any word. So this is nothing but probability of single word to entire corpus. So probability of that word occur in corpus. So we are taking one word and we are finding out probability of that word to the entire corpus. N represents complete corpus. So we use Bayes rule when we go to bigram, trigrams, etc. So first let us understand the formulas and then we can go to example. So in order to define this bigram probability, we can use this notation. So what it means? So as I said you before, what is meant by bigram probability? So bigram probability or the bigram language model, it's again a statistical language model which predicts the probability of a word in a sequence. How it will predict the probability of word based on the previous words. So it mainly consider pair of consecutive words which are nothing but bigrams, and it estimates the likelihood of occurring a specific word given the previous word in a text or sentence. Say if you see this equation here, I want to predict Wi. So probability of Wi. So that Wi depends on the previous word Wi minus 1. So this is nothing but probability of Wi given Wi minus 1. You can find it as count of, you can write it as count of Wi minus 1 comma Wi divided by count of Wi minus 1. So here we should calculate probability of word given last word. So Wi is your last word or previous word, and this Wi minus 1 is the previous or last word and Wi is the next word. So check how many times these two words Wi minus 1 and Wi occurred consequently. So first we'll find out how many times this Wi minus 1 occurred in the corpus, and then check how many times words Wi minus 1 and Wi occurred together, and divide the values. Next one is trigram probability. So here next word is Wi, right? So it depends on the previous two words. Previous two words are Wi minus 2 and Wi minus 1. So here find out. So here two words are already given, Wi minus 2 and Wi minus 1. So check how many times these two words occurred in the corpus, and divided by number of times these three words occurred consequently. So these three are three consecutive words, and these two words are already given. That means previous words. So based on this, you need to find out Wi. Next one is 4-gram probability, where n value is equal to 4. Again, just like previous case, we can predict the next word based on the previous three words. So previous three words are already given, and we need to check number of times these four words occurred consequently in the corpus.